We are now moving to Module 15. Module 15 will just focus on division of radical expressions. So we've already done adding, subtracting, and multiplying. So today we're going to solely concentrate on division. So let's go to the board and look at some examples. Again, I always want to relate what you're doing that's new to you to something you've already learned. So let's go back to basics. If I asked you to divide 32 by 2, you wouldn't have any problems. 32 divided by 2 is 16. So guys, what we're going to learn today is when I ask you to divide roots, that's a square root of 32 and that's a square root of 2. Both of those numbers are underneath the square root symbol. So this can be rewritten as 32 over 2. Instead of having them in separate square roots, they belong in the same one. Well, if we rewrite it like that, you all know what's 32 divided by 2. Well, that's 16 in a square root symbol. So because that fraction, we're dividing it, its answer is going to be in a square root symbol. Now, can that be the final answer? Well, no. What is the square root of 16? 16 is a perfect square, so the answer is 4. So the rule is, if both numbers are in a square root symbol, you divide them. It's really like rewriting it as a fraction. Okay, look at example 2. Go back to chapter 12. If I said negative 3x squared divided by 24x, could you divide that? Sure you can. First rule, in order to do division, you have to be connected by multiplication. This is multiplication, this is multiplication. So we can divide. What will we divide first? Right, we would divide the coefficients. Now, what can you divide 3 and 24 by? You could divide it by 3. 3 divided by 3 is 1, and 3 goes into 24 8 times. And we've discussed this. Where the bigger number is where the answer goes. 24 is bigger, that's why 8 went to the denominator. So we have in the numerator, we leave the negative sign in the numerator. We have in the denominator 8. We have in the numerator a 1. Now we're going to divide the variables. So now we go back and use our basic rules. X squared divided by x. When you divide, what do? You subtract the exponents. 2 take away 1 is 1. Where do you put that x? You put it in the numerator because that's where there's more. Remember, if you take that 1 away, it's gone. If you take 1 from 2, you're left with 1. Now, would you write that answer as negative 1x over 8? No, because the 1 is understood to be there. So negative x over 8 would be the answer. So we divide the coefficients, then we divide the variables. Well, today we got to do a root. The rule is what's on the outside gets divided with what's on the outside. What's on the inside gets divided with what's on the inside. So everybody, first of all, if we're doing division, how do we have to be connected? By multiplication. This is multiplication, they're side by side. This is multiplication, they're side by side. So first we're going to deal with the coefficients. I have a negative 3 over 24. Well, I can divide those both by 3. 3 goes into 3 once. 3 goes into 24 8 times. So I have negative 1 over 8. Now we're going to divide the radicals. Because 12 is in a radical sign and 3 is in a radical sign, we can rewrite this as 12 over 3 in a radical sign. That's what it means. It means both of them had a square root. Well, guys, we all know what's 12 divided by 3. That's 4. What is the square root of 4? That's 2. Where do you put the 2? Does it go in the numerator or the denominator? Well, it goes where the bigger number was. Who's bigger, square root of 12 or square root of 3? 12 is bigger, so the 2 would have went up here. So that would have made us have negative 1 times 2 over 8. Well, that's negative 2/8. And you all know from the previous chapter, you can't keep that because it's a fraction. We reduce it, and we get the answer negative 1/4. So just like multiplying, division works the same way. You divide what's on the outside, the coefficients, and then you divide what's on the inside, the radicals. And what's underneath the radical symbol stays there until you can reduce it. All right, let's try one more example. So if you look in your notes, let's look at our class notes at example 4. We have square root of 18 over square root of 50. And the directions say to divide. Well, we all know 18 doesn't divide by 50. Now, there's 2 ways to work this, and both ways will get you the same answer. So I'm going to work it both ways. One way to do this is say, okay, who are you square rooting? The 18 or the 50? Well, you're square rooting both. So we can rewrite it. Now, is 18 a perfect square? No, it's not. But we know how to reduce that. What perfect square is an 18? Oh, that's 9 times 2. What is the square root of 9? That's a 3. A 3 comes out. Can you square root 2? No, it stays inside. We're going to do the same thing with the 50. What perfect square is in 50? Oh, that's 25 times 2. What is the square root of 25? That's 5. Can you square root 2? Never. Now, if you look, now you reduce both of the roots. So you have 3 square roots of 2 over 5 square roots of 2. This is connected by multiplication. This is connected by multiplication. So what can we do? We can divide. We've already learned. If you divide the square root of 2 by the square root of 2, you're dividing the same thing. What happens when you divide the same thing? It cancels out. It makes the number 1. Is there any reason that you put that 1 there? No, because what's 3 times 1? That's still 3. And what's 5 times 1? That's 5. So the answer is 3/5. That's one way. A quicker way to work this expression would to be to realize, hey, inside this root symbol, 18 over 50 is a fraction. And didn't we learn, according to Please Excuse My Dear Aunt Sally, to do what's inside first? And even though you can't divide 18 by 50, there's a number you can divide them by. Let's reduce this fraction. We could divide both of these numbers by 2. And that would give us the square root of 9 over 25. So because there's a fraction inside a root symbol, we're just following rules where we can reduce this fraction. Now, it's reduced. It's in lowest terms, 9 over 25. The square root symbol belongs both to the numerator and to the denominator. Well, what do you know about 9 and 25? Hey, they're both perfect squares. What's the square root of 9? 3. What's the square root of 25? 5. So did we get the same answer? Sure we did. So the moral of the story is you got to just piece together what you've learned. We're doing division because we have the fraction part. If you didn't realize that you could reduce this, the symbol root belongs to both, and then you could have did the division. I chose to do the dividing first, to reduce it first, and then do the square root. Okay, have a good day.